tutorials, meaning you go through it. I just take you through one or two
This
of
call
the
is now
concepts.
being recorded.
We practice, then we move. So if you come to the class without practicing, then it means that you are going to drag the class behind. So please, I will entreat all of you to try your best to always make sure that you practice before coming. When you practice before coming, it will make us move early, and there wouldn't be a situation whereby you get to a point that you will have to struggle
This call is now taking notes.
in getting the solution to the various problems. And secondly, Unit 4 to 6 is very, very involving, and it involves a lot of tedious work to be done there. And that is where your presentations will be. So latest by the end of this week, Nkrumah and I will come together and get the groupings for you. You will have to start as soon as possible to start preparing for those presentations because they involve a lot. I'm saying it so that you don't come back complaining. So please, those who are not here, send the word to them that statistical method has a lot of formulas. You have to take it very serious. It's not like a reading subject that you can lie in the comfort of your room and say, I'll be able to do it. No, you need to give it a lot of attention. The times that I have extra time within the week, I'll let you know. But this week I am booked. Next week I am booked. So we'll look at next 2 weeks. If I have time, I'll let you know. Then maybe one evening, an hour to be able to catch up, because the 2 hours will not be enough for the section. No, we have to understand and also pick some examples to be solving. So that is just by the way. So now let's get the introduction, course description. I've placed the course outline on the platform. So this course presents the theory of hypothesis testing, which will include subtopics such as testing concerning means, differences between means, variance, proportions. It will also cover tests for associations such as contingency tables and goodness of fit tests. The course will also deal with correlation analysis, Pearson product moment correlation coefficient too. Then we also have the Spearman's rank order correlation, Kendall's rank correlation. Then it will also consider the subject matter of linear regression analysis and the method of least squares, prediction, and confidence intervals and regression diagnostics. So basically, by the time you are done with the course, you are going to have a fair idea, or you should be able to demonstrate knowledge in test of hypothesis, test for association, correlation analysis, simple linear regression analysis, and multiple linear regression analysis. So this is what basically you'll be looking at. So it means that test of hypothesis, test of association, correlation analysis will be for me to discuss with you. Simple linear regression, multiple linear regression will form the group presentations. Please, if indeed you are 100, then it means your presentations will have to break it down bit by bit so that everybody will be able to get a portion. So I've already told you, you have to give it your all. Practice, practice, practice. Please, if you are learning and you are confused about anything, go on YouTube, type whatever you want there. You'll get hundreds of videos there. You get somebody standing there to explain everything to you. Maybe what I will explain to you, you might not be clear on it. When you go on YouTube, you'll be able to get somebody there. But I'll also be putting videos on the platform for you to be able to get a clearer picture of whatever we'll be talking about. Any question about the course outline and the course? Any question about the course outline? Any question about what I've said so far? Any question? Reaction, please. Please, reaction plays a role. When we are online, we make do with reactions. Because
No
I'm not
question,
seeing
ma'am.
you still. Yeah, so you can just click on the smiley emoji and give me the reaction. Great. So without wasting much time, let's quickly zoom into today's agenda. So let's look at our agenda for the day for Unit 1. So we are starting with Unit 1, looking at what Unit 1 holds for us. So basically, we'll be looking at Unit 1, Section 1 to 4, because as we move, I'll be giving you room for you to also try some of the questions Please, you try the questions, you take a picture, you share it on the platform. That is how we are going to go. I'm not in your homes to check. If it's in a classroom, you will present your solution on the board. But because you're having it online, when you take a picture, you put it on the platform. Nobody should be shy about their results. If you check it and there's a mistake, we'll draw your attention to it. So if you share it on the platform, I mention your name, then you can tell us how you went through the procedure. That is how we are going to go. So section 1, we are looking at hypothesis and test procedures. That is what we are looking at. And section 2 for the unit 1, we are looking at tests concerning a single population mean. What goes into it, where we have a large sample. Then we are also looking at tests concerning a single population mean, when we have a small sample. Then we are looking at tests concerning a single population proportion. Then a test concerning a single population proportion when the sample is small. Then test concerning a single population variance. Hopefully, I'm hoping that the 2 hours should be able to capture us for the first 4 sections. Then we'll fix a day next week or next 2 weeks. Next week, I'm hoping that I can meet you maybe on Friday or something for us to be able to complete the section. So without wasting my time, we want to look at what goes into this part of this model. So in this model, which is entitled Statistical Method, you are going to be introduced to some statistical analysis. That is the general overview of the course. We are going to look at some statistical analysis, and these methods will include hypothesis testing, correlation and regression analysis, and analysis of variance. What goes into the first 3 units? The unit 1 to 3 will be devoted to hypothesis testing. And the last 3 units, that is unit 4 to 6, will be devoted on correlation and regression analysis and analysis of variance. In this unit, you are also going to learn about some common concepts that are used in hypothesis testing, procedures in testing, in hypothesis testing, and how to conduct hypothesis tests that are based on simple samples. So that is what basically we are going to look at. So for unit 1, by the time we are done, I'll ask you how to explain the basic concept when it comes to hypothesis testing. You should be able to tell me, how do we formulate the null and alternate hypothesis for a single population parameters? That one too, you should be able to say it. Then if I have a large and small samples, how do I conduct tests for a single population mean? Then a large and small sample, how do I conduct a test for a single population proportion? Then how to conduct tests for a single population variance. That is what we are going to look at. So for a start, looking at this section for a first start, what is hypothesis? When we talk about hypothesis, what is it? Please, you know how my class is very, very interactive. So I want to see more hands. Let me divide the screen into 2 so that I'll be able to see those raising their hand. And please kindly open your slide from your end so that you can rely on your slide too. Don't rely only on my slide, I beg you. So try and open your slide from your end so that your slide is your textbook. Open from your end. So when we say hypothesis, what is hypothesis? You can use your phone to search and let me know. What is hypothesis? What is a hypothesis? Maybe some of you have also come across that word before. When we say, what does it mean? Okay, it's a hand up. Beauty, go ahead.
Thank you, Madam. Please, hypothesis is a testable and educated prediction or explanation for a specific phenomenon, serving as a foundation for scientific research.
Great. So I like that scientific research and phenomenon over there. Thank you very much. Any other person? What is hypothesis? That is what we are looking at. Can we get one female male to balance the equation? One male to balance it. Let's get a male to balance it. Okay, So now we can continue. When we talk about hypothesis, we are talking about a statement or assertion about the value of a population parameter or about a characteristics of a probability distribution. So I have a population. I want to know the characteristics of it. I want to know my take on that population. Then getting to know it and drawing the conclusion is what we call the hypothesis. So whenever I want to look at a statement or assertion about a population parameter, looking at their various characteristics, we say is what? Hypothesis. So the characteristics what come to play. As we move on, you get to know what we mean by the characteristics. Mostly, it can be a claim about the value of several population parameter or about the form of a probability distribution. So it could be that there is a probability that I performed on a particular sample, and I want to look at the characteristics of that population. Maybe I can come to the online group. I want to find out how students are able to participate in online classes. When I sample some few students and I want to look at the various characteristics and draw my conclusion, that act of picking them to look at their various characteristics is what we call hypothesis. That is what we call hypothesis. So let's consider some few examples. For example, we have a mean age of students in College of Distance Education in 2017, which is equal to 36 years. So in writing the hypothesis, we write that mean is equal to 36 years. I believe, as I'm saying, you now can see the symbol for mean. So the U sign there stands for the symbol for mean. So now the assertion or the claim about the mean population of the people is that I say their mean is equal to 37. So I've given. Please, when I'm done, I'm expecting you to also come in with your hypothesis, some hypothesis you think, some statement that you think are also hypothesis. Or we can look at some male and female issues in Ghana, whereby I have the proportion of male students or male Ghanaians to be P1, and I say that male Ghanaians are lower than female Ghanaians. So maybe I can even use mathematics to say that male mathematics students in Ghana are higher than female mathematics students. If that is the case, then I'm going to get P1 greater than P2. Let's assume I'm using P1 to depict or represent the male, P2 for the female, then I'm going to get P1 to be greater than P2, or P2 is less than P1. That is what hypothesis. Or you want to look at the weekly power distribution that perhaps you get in a certain village or in your area. How well does Ghana water flow or electricity? Maybe you want to look at it and say that, oh, averagely, I'm able to get electricity at this particular point. You can also use that to write an assertion, and you call it what? Hypothesis. So I think we are getting a clearer picture of what hypothesis is. So I want you to also give me an example of hypothesis. What are some examples of hypothesis that you can also think of based on what we have? What are some examples of hypothesis that you can also think of? Beauty started nicely. Let's get another person to also continue. What are some types of hypothesis you can think of? Yeah, Stephen.
Yeah, so ma'am, I'm going to take a proportion. That's the proportion of that's P1 of male or males of this academic year for UCC larger or greater than that of the females. So I can say that that's the P1, which is the males, is greater than P2, which is the female.
Thank you very much. Or I went to a class, I decided to check their mean age and realized that the mean age of the students in the home econs class is 20 years. So I'll write mean is equal to 20 years. And that is the hypothesis. So I think we are all fine when we talk about what an hypothesis is. We can understand it. So an assertion about the value of a population parameter. And the population parameter can be the mean, it can be the proportion, it can be the standard deviation, it can be anything. So as we move on, we'll get to know about some of these parameters. Please, if you have a question, feel free to raise your hand to ask the question. Now we are looking at some types of hypothesis. there are two major types of hypothesis. We have the null hypothesis and the alternate hypothesis. So you are going to use your phones to search. In 5 minutes, you raise your hand and tell me what the null hypothesis is and what the alternate hypothesis too is. Please, these form the foundation of your study. So if you don't get this foundation very well, you will not be able to understand anything. Stephen, your hand is up. Is it to ask a question?
Sorry, madam. I forgot to put
Okay.
it down.
So we are searching in the next 5 minutes. What is the null hypothesis and alternate hypothesis? Abochi, do you want to ask a question?
No, please, I want to react to null hypothesis.
And let's give ourselves 3 minutes so that those who are not on the same page, they can also search and come in with theirs. So Abochi, after 3 minutes, you come in, okay? So 3 minutes, let's search and come up with that. Okay, Abochi, let's go. What is the null hypothesis? What is alternate hypothesis?
Okay, thank you, madam. For null hypothesis, it says that nothing will happen or there will be a change in something. That is for null hypothesis, or it means there is no effect or no relationship about. So let's say you are comparing two objects or two events. So you are trying to draw, or you are trying to compare or juxtapose the two. So by so doing, null hypothesis talks about what is the relationship between the two events or the two objects.
Thank you very much. Okay, go ahead. Land, please.
For the let's say the alternative hypothesis, that one, it talks about the where there is a change, or what, or if, let's say, something will happen or there is a change in something. Let's say I know that, for example, if I am a farmer in a farm, when there is rain, definitely I know that my crops will do, or if there's rain at a new season, my crops will grow well. So then I'll be able to harvest well. So if there is no change, if there is no rain, that will affect the yeah.
Okay, thank you very much, Abuchi. Grace, your hand was up. Grace. Yeah, Grace.
I'm not Grace, but
your
I'm
hand
using. Yes, so I'm using the Grace.
So I wouldn't know you're not Grace, so go ahead.
All right.
So
So
you
when
are
you talk the null hypothesis, it's
What's your
talking
name,
about
please? What's your name?
My name is Augustine. Augustine.
Okay.
When you
Go
talk
ahead,
about the
Augustine.
null hypothesis, we are talking about nothing special will happen. And then the alternative hypothesis is like opposite to the null hypothesis. So that one, something interesting will happen.
Okay. Thank you very much. So when we talk about the null hypothesis, we are talking about the assertion that is initially assumed to be true. So let's think of an example now. An assertion that initially is true. So as I'm coming online, maybe the assertion that I'll come online with is that majority of the people I'm going to meet for statistical method are going to be male. That is my null hypothesis. The alternate hypothesis later comes in to contradict what the null hypothesis is. Please, I'm giving an example so that when I get to your point, you can also give me an example. So my null hypothesis is that majority of online mathematics students are males. That is my null hypothesis. if I am asked to state the alternate hypothesis, it will be that majority of them turn out not to be what? To be males. That will be my null hypothesis. Or the null hypothesis, or sorry, the alternate hypothesis can also be like the majority of them are less males or more males, or they are equal to the males. Depending on what the null said, you come up with the alternate hypothesis. So mostly the null hypothesis is what we call the researcher's hypothesis. So I, as a researcher, this is what I think. Then the alternate hypothesis comes in to contradict what the null hypothesis said. So we are told that hypothesis testing involves the use of sample data to decide whether the null hypothesis should be rejected or not. Please take note of this. It's very important. Mostly when we're doing the rejection, we reject the null or we fail to reject. If you are failing to reject the null, it means that the alternate what is true. So for example, I told you that majority are males, but then after my investigation, I realized that majority are not males. Then it means I'm going to reject the nulls and accept the alternate. The alternative say that majority are not males, so I'm going to accept it. But let's assume that after my research, I realized that indeed majority are males. Then it means what I'm going to do is that I am not going to reject the null. I am going to accept the null. Please, we are going to solve a lot of questions on this and you will see. So based on the evidence that you have, you decide whether you should reject the null or you should accept the null. Now, based on that, before I go to my board to do some writing, what example can you also give me to show that this is alternate hypothesis? So let's pick examples from your side too, so that I get to know that you understand it. So let's get an example. Abel, Kwashi.
Okay, madam. Okay, madam.
Abel, Kwashi, go ahead.
In
Abel.
case you are about to go to class. Yes, madam. In case you are about to go and teach in the class, you have the knowledge that, whatever you are going to teach, because you understand that the thing is easy to understand. So your now is that every student will understand whatever you're coming to teach. But at the end of the lesson, and then you realize that only a few understand or majority understands. That means over there you and then pick the alternative rather.
So I want you to state it like I did mine. So then now majority of online mathematics students are males. The alternate majority of online mathematics students are not males. So if I go and do my investigation and realize that majority are not males, then it means I'm picking the null. It means, but if I realize majority are not males, it means I'm picking the alternate, which says majority are not males. I'll reject the one I said at first, that they are males. But if I conduct my research and realize indeed majority are males, then I'll take away the alternate and maintain my null. So that's how I want you to state it for me. You were on point, but I think you should come back again. Yeah. Edu.
Okay.
Edu, then Dramani will come in. Edu, we are calling Edu. Where is Edu? Okay, Dramani.
Okay, madam. An example of a null hypothesis can be that
Edu, please, your line was breaking. Please come back again. Your line was breaking. Please say it again.
Can be students who study. Okay. Okay, madam. An example of a null hypothesis can be that there is no difference in exam scores between students who study and those who do not study. But when it comes to the alternate hypothesis, it can be that students who study perform better in exams than those who do not. After
You will see that there's difference. Okay, Edu, thank you very much. We get the point. Please mute yourself. Your line was breaking. Samson, last one. Samson, last one. Samson, give us a last one, then we can continue.
Okay.
Samson, last one.
Example of the now. Okay. Example of now hypothesis can be like, in 2028, the general election, which will be content, male, it will be most male candidates. But after I have observed and I gather my information, I got to know there's more female candidates contesting for the 2024 election.
Okay. So initially you were
That
thinking
one is
more
alternative.
would be great. So at first you were thinking more males, then later you were perhaps when you went in, you realized that no, it's not true. So please, mostly if you are stating the now goes in the alternate goes in the opposite direction of the now. So majority are males. Then the alternate would be the majority are not males. That is how we mostly state it. If I want to state the null hypothesis is represented by H naught. So this is how we call it, H naught. And the alternate hypothesis is represented by H1 or HA. Please take note. So the H naught is the null. So the null hypothesis, as I've said already, it's more or less like the researcher's assertion. What was the researcher thinking before you went there? So he was thinking the majority of students are aware of the usage of AI to teach. But when he went, he realized that it's not true. Majority of university students do not use AI in teaching, or they do not use AI in their learning. So that is the conclusion you can draw. So I believe we all have a clearer picture of that. So let's look at the various classification. In this now and alternate hypothesis, it can be classified in various components. So in any hypothesis testing problem, the null and alternate hypothesis may further be classified as simple or composite tests. So it can be described as either simple or composite test, or as one-sided or two-sided test, depending on how the test is set up. So depending on how I set up the test, I can tell whether the test is simple or whether the test is what is composite. Now let's look at a simple test. Suppose that the parameter of interest in a statistical test problem is, so let's assume that I am using this to represent a test item that I want to test. Then the hypothesis testing can be classified as either is composite or complex, depending on what values it will take. So let's assume that I'm using X to denote hypothesis test that I want to conduct. Whatever value that it will take, that will determine whether it will be simple or it will be what? It will be composite or complex. So if let's assume that the S value that I want to represent, it takes on a single value, then both the null and the alternate hypothesis are called simple hypothesis. So if I get a single value for whatever I'm looking for, it is called simple hypothesis. These are possible objective questions. However, if I get answers or solutions that are double, then it means I'm getting composite. So simple ones may be in this form, that at first H naught was such that, let's say the mean gave me 20. So I went to class, I conducted a test, and I realized that the mean of the students in the test, their mean score was 20. Then the alternate hypothesis says that the mean square is not equal to 20. Then it means that I'm going to get a single value for it. Then it means I am conducting a single test. Or the alternate test also say that it is also equal to 20. Then it means I'm conducting a single test. But then when you go to the composite one, you realize that in the composite, you are going to get more than one value. So let's assume that I went to class and realized that the mean test of the student is greater or equal to 30. That is what I got. It means that in the alternates, what is going to happen in the alternates? If I'm getting it greater or equal to 30, what does it mean? It means that I'm not going to get a single value for the mean. there are going to be different values that I can get. So if it is greater or equal to 30, it means I can either get it greater than 30, or I can get the mean equal to what? 30. Why? Because of this equal sign there. It means there are two things that are possible will be the outcome. So we can write and write and write, or I went to conduct a test and realized that, or I wanted to check the weight of some students. Let me use W for weight. I realized that their weight is greater or equal to 50 kg. That is what I realized. The alternate hypothesis would be that their weight would either be greater than 50 kg, or their weight to be equate to what? Equal to 50 kg. So it means I'm going to get what? More than one parameter. And this is different from where it gave me a single value. So please take note. When I'm getting more than one, it means it's complex. I'm seeing a hand up. Question time, please. Question,
Hello,
Bernard.
madam.
Yeah,
Yes.
Bernard, go
Okay.
ahead.
So, from the explanations we've had as to now and alternative, and with the example you are giving now, I'm quite a bit confused because from the explanations we said, let's say the now is the status quo, and the
The
alternative
null is
is
what? I didn't get you. The null is.
it's like the status quo. It's like the status quo. What is there? And the alternative is more or less like what we are trying to prove that is not there. Okay. Now, with what you said, as in the examples you gave, that each knot is equal to is greater than or equal to 30. If we are also to say that in terms of alternative, shouldn't it be the opposite of it? That it's not greater or equal to 30. I don't know if you get my question clear, but that is what is coming into my mind. I don't know. I
If
don't know
it
if you
is
get.
not, no, I get your question very well. But if it is not greater or equal to 30, oh, I get what you are saying. Well. But what I want to say is that if it is not greater or equal to 30, then it means that you are going to get two things happening. So my focus is I'm not looking at the not aspect of it. I'm looking at what are the possible outcomes. So when I was coming to the class, I thought there's some noise from the background. Where is it coming from? When I was coming to the class, I thought the mean for the exam score was 50. But then if it is not 50, then what does it mean? It's either it's going to be equal to 50 or it's going to be greater than 50. If you are saying not, then you should tell me then what is happening next. I hope you are getting my point.
Yes, please. Yes, please. Hello, madam.
Oh, I didn't know I've muted myself. Hello, can you hear me?
Yes, please.
Yes.
My hand
Yes.
mistakenly muted. So what I was saying is that I can see what you are talking about. When you are talking about the not, you are talking about the one-sided and two-sided test. We are yet to go there. But in this case, we are trying to explain what the various hypotheses can be. You can get a single hypothesis whereby the value you are looking at is just a single value. When I'm testing for just the mean, then I thought that the mean is 30. But when I realized the mean is not 30. Then I draw the conclusion. That is what we call a simple hypothesis. But with a composite hypothesis, I thought the mean was greater or equal to 30. But later on, when I realized that it wasn't greater or equal to 30, then what am I going to get? I'm going to get it less than 30 or equal to 30. So two things are going to happen. Because I'm getting two things or more being happening, that is why we call it composite. So with respect to your question, that will be catered for in the one-sided and two-sided test. Please, are we good to go? Any question? If we are good to go, please, the reaction, the thumbs up will make me know that you are good to go, then we can move on. Great. So now we are going to look at one-sided, and that will take us to the question that he asked. We have one-sided test and two-sided test. There are times that you are going to get all these happening. Under what circumstance do we say that a test is one-sided? And under what circumstance do we say that a test is two-sided? So when both the null and the alternate hypothesis are composite, please take note. When both the null and the alternate hypothesis are composite, represent one side of the parameter space around the same value, then we say the test is said to be one-sided test. So when it is around the same parameter, then we say that the test is one-sided. Let's look at an example of one-sided. Then you can also tell me one-sided test. So example, we have either one-sided tests are called one-tail test. I will illustrate to you as to why it is called one-tail test. So example is this. Let's assume that I went to a class and I was checking maybe their mean or equal to a particular value, and I'm checking it against their mean less than that value. Because I am checking only one thing, which is the greater than, then I am going one-sided because I am not bringing any equal to in the picture. What I'm testing is just one. But then when you go to the two-sided, in this instance, it's either I will say it's equal to or not equal to. So the moment I bring the not equal to, it means that I am going two-sided. So please, let's look at the difference again with it. With respect to the one-sided, let's assume that I am told that the mean is greater or equal to 0. Then I'm testing it against the null, which says that it is greater than 0. Just that one parameter for the null hypothesis is what makes it a one-sided. So it means the null hypothesis and the alternate hypothesis both play a role for you to determine whether your test is one-sided or two-sided. So before you start solving any of these hypothesis tests, you should ask yourself, what type of test have I been given? Is it one-sided? Mostly, you will see the not equal to sign. Please take note. The not equal to sign will help you know that what I've been given is two-sided. So on your own, can you give me an example of a test of a one-sided and two-sided? One-sided and two-sided. Maybe when you say it, I can write it on the board. Can we get an example of one-sided and two-sided? So let me use my example here that I went to class and realized that their weight was greater than 50 kg. Then what is going to happen is that I later on realized that their weight was less than 50 kg. Because I'm using only the less and the greater than, these single parameters, it means this is going to be a one-sided. But then when I went, if I'm testing that their weight is equal to 50 kg, and I am testing that against their weight is not equal to 50 kg, because of the not equal to sign, it means I am going to get a two-sided test. The way we represent the two is different. We represent the one-sided in a different way, and the two-sided will also be represented in a different way. So can we throw the light on you whilst you also give me an example of a one-sided tail or two-sided tail based on the example that we have in the model and what I've given you? What example can you also give? So you should give us what your hypothesis is. Maybe you want to check students' age, students' height, students' marks, students' something against something. So let me get that right. Anybody to give it a try? Grace, stop the clapping and start. Okay, Steven.
Please, madam, on one-sided. Yeah. So let's
Okay,
assume.
Steven, let's go.
Yeah, let's assume that I went to a class to know the number of fair students over there. So one-sided. Getting in there, I realized that the number of ladies, fair ladies, are less than the number of fair guys.
So what is your null hypothesis?
So my null hypothesis here is
You should give me a value for it. You should be able
okay.
to give me a value. Yeah,
Okay.
if you want to.
So the
Yeah,
null
represent the
hypothesis here,
person.
that is 10.
Come again.
Null hypothesis, madam, 10.
What are you using to represent the ladies? So you
I'm
need to
using
get a variable, just as in algebra, we use variables. You should be able to get a variable to represent it.
I'm using L to represent ladies.
L.
L,
Okay.
yes, please.
So L.
And then the male, which is M.
What
L,
is
which
it?
is
What is your value? No, you can't
10.
write that of the male. If you are
10.
going with the L, it is L you go throughout. So L, is it
10.
greater than something or less than something?
It is less than less than 10.
The ladies are less than 10. So what would
Yes,
be the
please.
alternate hypothesis?
The alternative that's L
They are greater
than.
is greater than 10.
Yes, please.
Excellent. That's all. So this is a one tail test. So this is one tail. This is one tail because we are dealing with just these two. That is all. But let's assume that he brought in the equal sign and not equal sign. Then we are moving to two tail. Please, are we fine? Reaction. Let the flowers flow. Then I'll know we are fine. Are we fine? Okay. So I believe we are fine now. We can continue from there. Sorry about that. My mother just jumped up. I think we can continue from there. So far, you know what hypothesis is. When we talk about null hypothesis, you know it is a researcher's assertion. Then the alternate hypothesis is what you want to prove based on what the researcher is saying. So we are going to very soon resume into solving some questions where we'll be using the one tail and the two tail. So let's look at, how did this thing jump up like that? A minute, please. So let's quickly go into looking at some of the errors that we can commit. As researchers, we cannot throw away committing of errors. By all means, I might go and conduct a research and come up with a particular error. So we are going to look at some types of errors that we can commit. So I'm giving you 5 minutes to do a sober reflection of these types of errors. Then after 5 minutes, please raise your hand and let's discuss it. So errors in committing testing. So look at these errors and tell me your take on them. If it is possible and you want to also come up with your own error or your own example with respect to the errors, it's possible. So let me give you an introduction to what we are looking at with respect to the errors. So in any hypothesis testing problem, the null hypothesis, which is the H naught, can either be true or false. We've already said it already. So what the researcher said or what the researcher is saying can either be true or false. That is what we are saying. But at the end of the test, there are two possible conclusions that we are going to draw. It's either I am accepting what the researcher is saying or I am failing to what, or I'm rejecting it. So it's either I will reject it or I will fail to, or it's either I will fail to reject it or I will reject it. That is it. So it's two things. It's either what you are saying is true, I will take it, or it's not true, I will not take it. That is what it means. By research, we say reject, then fail to reject. Please, these are the terms that we use. We will not say, I will not reject. No, we say reject or fail to reject. If you are failing to reject, it means you are accepting. But we don't say we accept, we say fail to reject. So if that is the case, then 4 possible things can happen. So please look at these errors. We have 4 different types of errors that can happen in research. Then let's discuss it because these are the realities that we'll be facing if you are supposed to write our thesis. Even at the master's level, these errors, we are supposed to get familiar with them. So that is why I'm giving you 5 minutes. Look at the 4 errors, then raise your hand and tell me how you understand these errors that are possible to be committed during hypothesis test. So I'll mute myself for 5 minutes When you are done, I will mute, then we'll discuss it. Okay, shall we discuss it now? What did you gather from what you read? We are looking at the first error, type 1 error. It's one of the common errors that we can encounter. What goes on in the type 1 error? In the type 1 error, what goes on in the type 1 error? In the type 1 error, what goes on? So what happens in the type 1 error? Bernard, I've not heard of your voice. Where is Nkrumah? Nkrumah, are you back online?
Please, I'm with you.
Okay. So then break your voice for us. Type 1 error. You can even read it, then we'll discuss it. Please, you can refer to it from your end because I have to divide the screen and see those who are raising their hand. So type 1 error, what goes into type 1 error? Eric, what goes into type 1 error? You are clapping, so don't clap. Just Abel Kwashi. Abel.
Yeah, madam.
Yeah, go ahead.
I think what they are trying to say here is that
It's not about what you think.
the
So say it.
researchers
It is so.
hypothesis, yeah, might be true or it's true, but at the end of the test, you mistakenly reject it,
Excellent.
and that's what they are trying to say here. That it's a wrong decision.
Excellent. Great. Let's think of an example. So what
Yeah.
we are saying with type 1 error is that when I went in to conduct the test, yeah, Stephen, before I come in. Yeah, Stephen. Stephen.
Madam, with the
Yeah,
example,
Stephen, go
as you
ahead.
rightly, with the example, you went to a class and then conducted a test. You assume that all the a class of 20, all of them are going to get 100. That's 100%. But after the test, you realize that no one even got 50. out of 100. So though it was, you only assume that they were going to get 100, but after the test, they all failed based on the results. So you can say that yes, type 1, there's an error after the test was conducted.
Okay. Is Steven not messing it up? Okay.
Madam,
Let me get
Madam.
another hand. Yes, who is calling?
Abel.
Yeah, Abel.
Madam, please, I think what my brother said is rather the opposite. I
So
will say that,
that's what I'm saying. Steven is messing it up.
yeah, I will say that. Say
Yeah,
the
Abel, go ahead.
researchers' hypothesis is that all the students will get 100%. And after conducting the test, it is true that they got the 100%.
Yeah.
In a decision that you make, you reject it instead of fail to reject, but you rather reject it. That's what they are
Great.
saying in the one.
Yes.
Yeah.
So I think it's clear now. Steven, are you clear now? So when I came to the class, the assertion that I had is that online mathematics students are full of males. But later, when I came to test, I realized that indeed they are full of males. But still, I'm rejecting it. I'm still saying that they are not full of males. They are full of females. Meanwhile, the test that I did said they were full of males. So I made a little error. So that error that I made me reject the now, which was the truth, or which was the researcher's claim. So the researcher's claim was that all Friday borns are nice people to be with. That is what the researcher was saying. But then when I conducted my test, because of some errors that I made, the alternate hypothesis was that Friday borns are not nice. That is the alternate hypothesis. But then after conducting my test, I made a mistake. Instead of accepting that they are all Friday borns are nice, which is the now hypothesis, based on my research, that is the result that I got. But because of the mistake that I made, I rather said Friday borns are not nice. And that is what we call type 1 error. It's one of the commonest errors that we commit in our various researches. Then the type 2. Type 2. What goes on in type 2 error? What goes on in the next one? Okay, let's look at the second one. What goes on in the second error? We are looking at the types of errors that we can commit when we are conducting a test. We are looking at the types of errors. So the second one, please, somebody can just read it for us, then we'll discuss it. I want us to read it to get the emphasis very well. So somebody should just read it for us. Bernard, Mauli. Bernard.
Okay. Hello, madam. Hello.
Yeah, Bernard, go ahead.
Okay, so in the type 2, where's my type 2? All right. Hey, madam, sorry, I can't find the type 2 explanation.
It's not the type 2, just the second one. Read the second one, not the type 2.
Okay. We are saying that the now is false, whether that's it, but the now hypothesis is false, and it is rejected at the end.
Okay. So the second one, we are told that if the now is false and it is rejected at the end of the test, this is a correct decision. What does it mean? Can you give me an example? The null is false and it is rejected at the end of the test. This is a correct decision. Based on what we said so far, I want you to give me an example so that I'll know that you have now gotten the picture of Mauli. Yeah, Mauli. Okay, Eric.
Hello, can you hear me now?
Yeah, Mauli, yes. Go ahead.
Hello, madam.
From where
Eric, please wait. Mauli, go ahead.
From where I stand, I see it as we missing an opportunity. So we are saying that it happens when there is a real effect or there has been a change happening, but our test is failing to notice the change. Okay, something is happening, but the test we are conducting is failing to notice the change. That is where we have the type 2 error.
No, we are not talking about type 2 error. Hold on before the type 2. We are looking at the second point. Yeah. So you
The
come in
second
with the type 2 later. Yeah. So the second one, which says that your null is false and you rejected it. If you do that, it means you have taken a very correct decision. We are finding out what does it mean.
Oh, okay, madam. I'll let my colleagues also.
Great. Eric, go ahead.
Okay.
Hello.
Madam, I want to give an example.
Hello.
Yeah, Eric, go ahead.
Assuming a researcher came out that about 30% of the class is brilliant, and he came to at the end, he found out that about 70% of the class is brilliant. So he decided to reject the research. That is the example of the second.
Great. So most of the all online students mathematics classes have more males. Then when I conducted my test, I realized that no, they have rather more females. Then indeed, now that I said they have more males, I'll reject it. If I reject it, it means I've really made a very good decision, correct decision. Another correct decision is when the null is true and it is not rejected. When the null is true and it is not rejected. So all online students are males. Then when I conducted my research, I realized that indeed all of them are males, and I picked that up. And in conclusion, I wrote that, oh, indeed, what I said was true. They are all males, they are not females. Then it means that my decision is correct and I've made a very good decision. Then the type 2 error says that when the null is false and it is not rejected at the end of the test. So can we think of an example? When the null is false and it is not rejected at the end of the test, there is a wrong decision. And this is what we call the type 2 error. The null is false, but you did not reject it. So instead of you reject it, you failed to reject it. You accepted the null. Meanwhile, you are supposed to reject it. We call it type 2 error. Can we think of an example? Can we think of an example of the type 2 error when the null is false, and it is not rejected? Can you think of any real example? Yeah. Steven.
All right, madam. So one example is prescribing a medicine to a child, knowing that though the child suffered from a stomach bed, you are prescribing a headache medicine. So after giving the medicine, knowing that the child is suffering from stomach bed, giving headache, you know that the decision you've taken is wrong. Instead of giving stomach, you rather give headache.
Okay, great. So he's giving us a real life example. You have rather given the child or diagnosed the child, giving the child the wrong medication. Thank you very much. Any other example where the null is false and it is not rejected? So all online students, majority are males. When I conducted my research, I realized that the majority are not males, but they are rather females. So instead of me rejecting the first statement that majority are males, I did not reject it, but rather I accepted it. So when it is false and I have not rejected it, that is type 2 error. So if it is false, you have to reject it and take the alternate hypothesis. But if it is true and you reject it, you are committing a type 1 error. That is the difference. So please, let's take note of the difference. So these scenarios have been placed in a table form for us. Later on, we can go through it. So later on, please, you can go through it. Question time, please. Question time. Okay, so just as we've mentioned already, in conducting these hypotheses, we use what we call a test statistics. And the test statistics, we are told, yes, please go ahead, question.
Yes. So I want to find out. So let's take, for instance, our test results, like as in the null hypothesis. The hypothesis was false, and our test is also maybe an error we made. Our test also came out as false, and at the end of the day, how did I? Oh, yes, our test also came out as false. How do we conclude on that?
Bernard, please come again.
So the now our test was false. Okay, so our H naught was false, and our alternate also was false. How do we conclude on that?
No. Your test cannot be false and your alternate is not possible. No.
Madam,
My
maybe
people, based on what we
there
have
was an
discussed,
error.
is it possible? No.
No, it's
Your
not possible.
you can't get one false, one false. No.
Okay.
Then on what basis were you going to conduct the test? No,
Okay.
you should have a basis. The point is that you can have a basis, but maybe your basis can be either true or false. That's all. So as you are going with a basis, you only have two answers you are going to get. Either your basis is false or true. So I am coming to see Bernard. It's either I go and see Bernard as a fair guy or a dark guy. That's all. I cannot say I got it wrong. Bernard is not fair. He's not that. Then he's what? So it's two things. It's either I get you to go to the A or I get you to go to the B. That is it. So you can't be in between. So let me give you an example. When I was doing my MPhil, I conducted a research on challenges that teachers face in large classes. So my hypothesis is that teachers indeed face challenges in large class size. So what am I going to get? It's either I go and the teachers will tell me, Madam, you are lying, we are not facing any challenge. Or I'll go and the teachers will tell me they face a challenge. So there's no way that I'll go and the teachers will tell me we are not facing, we are facing. No. Always you get one clear point based on what you are saying first. I can also state it that, but please take note, that even brings up this point. When you are stating the now, we don't put negative in the now hypothesis. Please take note, it's very important. So I will not go and say that mathematics teachers in Tema do not face challenges in large class size. So the test hypothesis will be that mathematics teachers face challenges in large class sizes. That is why when we were doing the two-tail, you realize that the not equal to sign was coming to the alternate hypothesis. So the now always has positive vibes. Then the negative vibes will go to the alternate, if I should put it like that. So if you are done, it's either you are accepting the positive vibe or the negative vibe was the truth. So that is it. Yeah, great. Thank you very much. Any other?
Yes, madam.
Please go ahead.
Madam, the errors.
Yeah.
Even though we are having 4 points over the bar, looking at it, the point in 3. Madam, are they errors? That's what I'm not getting clear. Because error is if you're not able to get the thing correct, that's the error. But they stated the point 2 and 3 as the right decision to make, but they are still considering it as error.
Okay, I get you. You are right. So that is not an error, eh?
Yes, please.
How should we call that? So that we'll do an update of the model. So how should we call that? Tell me, so that I'll call the professor who wrote it, then we can do that. We should call it out. Oh, say it. We are giving you the opportunity so that we add your name to those who wrote the model. Say this is a fine opportunity. Stephen wish you will get this opportunity. He didn't get. You have gotten it, so make use of it. So I get you. So it's not an error. This is with respect to the decision that you take, right?
Yes, please.
Great. So this is about decision. So I think that is clear. But it's also possible that you also make that decision of not accepting it. So that can also be an error. So it can be an error depending on where you stand. My people, what do you think? I hope you got the question he's asking. He says the second and the third points are not errors. They are correct. So if they are correct, it should not be called error. But I think you are right. So I think because of time, we can continue. So just as I was saying, we have what we call a test statistics. And the test statistics is what we use to estimate or the parameters that we use in hypothesis testing. So as we are moving on, we are going to look at some of these test statistics that we'll be using. So if there's a large difference between what you expected, please take note. If there's a large difference between what you expected, if there's a large difference between what is expected under the null hypothesis and what is observed in a sample, then the null hypothesis is rejected. Please take note. I will take that again. If there's a large difference between what you expected under the null hypothesis and what you observed in a sample, then the null hypothesis is what is rejected. So it means that nothing should go beyond the null hypothesis. Almost every time, it should be rally around the null hypothesis. So what I assumed it to be, if I realize that it's going beyond that figure, then it means I am going to reject whatever claim I am saying. If it happens that way, then the result is said to be what? Statistically significant. Please, I believe you can see what has been highlighted in bold here. These are the possible objective questions you can get. So if there's a large difference between the null hypothesis and what I observe, then I can say that there are statistically significant values there. So I will do the rejection. On the other hand, if the difference between what I expected and what I observed is small, then it is not enough for me to reject the null hypothesis. So I'll say it's statistically not significant. So not statistically what? Significant. So there's no need for me to reject it. So for example, when I was coming to the class, I assumed that the weight of the student was 50 kg. But when I went, I realized that majority of the students, had a weight of 100. That is too much. Then it means I have to reject the null hypothesis. But then if I come, that is what we call statistically significant, because the difference between what I observed versus what I got is too huge. But let's assume that when I came, I thought the student's weight to be 50 kg. But later on, I realized that it was 50.5. 0.5 difference is not too huge as compared to the one that the difference was like 50. So it means that I am not going to reject the null hypothesis. As we move on, we will get a clearer picture of this when we start using them in questions. Then there are two approaches to determine whether to reject the null hypothesis or not. There are two ways that we are going to use to tell whether my null hypothesis should be rejected or not. The first involves the determination of what we call the region or critical region of the test. So we have what we call the rejection or the critical region. So I'm going to my board to draw for you to see. So this is what we call a normal distribution curve. Very later, I'll ask you to search and tell me what a normal distribution curve is. So it is bell-shaped like this. Now, when I shade, where I'm shading, these are what we call the tails. So let me use the blue to indicate here. So these are what we call the tail. These are the tails. So these are the tails. So here is what we call the right tail. I'm using RT. Then here is what we call the left tail. So where I've used the blue is what we call the tails. So this is a typical diagram of what we call a two-tail test. So if I'm going to get a two-tail, dimension of two-tail, when there is not equal to sign, sorry, it's going to be a two-tail. But if I have a greater than, it means it to be right tail. If I have a less than, it's going to be a left tail. Please take note of the difference. Now let's assume that I want to know which one is the rejection area. Now, anything that goes to where the blueprint is, where the left tail and the right tail is, where I've shaded, anything that goes there is what we call the rejection stage. So if I work with you and I realize that, so let me draw another one and give you a clearer picture of the rejection stage. So the shaded portions are what we call rejected regions. So these are what we call the rejected regions. Then where I'm using the red is what we call fail to reject. So as we are going to solve, whatever value that we get, if we get you and you move to where I've written the RR, it means I'm going to reject you. You have entered the rejection region. But if I work with you and the value that I get is at where the FR is, it means I am failing to reject. If I'm failing to reject, it means I'm accepting the null hypothesis. Don't worry, we'll pick more, you'll get to know. So one way that you can reject the null or accept it is through the rejection region. That is what I have shown to you in that diagram. And in doing that, we use what we called the alpha values. We use what we called alpha values, represented as this, or some books use the A. I think your model used the A that looks like this. So these are what we call the alpha values. What are the alpha values? If I want to conduct a particular research, I'll go in with some level of confidence. So let's assume that when I went to conduct the research on the class size, all things being equal, I went in with a confidence level of 95%. So many things goes into this 95% confidence interval. It can be that my instruments were fine, everybody was on point, there was no bias, I made sure my people understood everything. So these things come together to make what we called confidence level. So when you see some books, they use CL to represent confidence level. So the confidence levels come in what? In various, what do we call it, percentages. So you can come with a confidence level of, let's say, 99%. It starts from 99%, or confidence level of 90%, or confidence level of 95%. These are the ones that we mostly work with. So if you have a confidence level of 99%, it means that I am going to make an error. And the error is what we represent by what? Alpha. So I'm going to make an error. So if it is 99%, then it means I'm making 1% error. 1% error is the same as what? 0.01. So that is why you are seeing alpha 0.01. So now let's go to our slides and look at the values of the alpha. So we are looking at the various level of significance. So the alpha are the various errors that perhaps I might commit. So you know that what you should notice that in research, we make room for errors. But when you look at alpha is equal to 1%, mostly in the medical field, that is the error that they make, 1%. Because in medicine, if you make an error of 5% or 10%, a lot of people are going to die. So let's assume that I want to conduct a particular research to find out whether a medication that I'm bringing will be okay for people. Then my confidence level should be 99%. I should make an error of 1%. If I make an error of about 5% or 10%, a lot of people are going to die. So alpha with a 99% confidence interval should give me 0.01 alpha. And the alpha is going to play a role in the critical region. So I'll connect the alpha in the critical region for you to see. If my confidence level is 95%, then it means my significance level is 5% or 0.05. However, if my confidence level is 90%, then it means my alpha will be what? 10%. Question time. Confidence level, alpha level. Yes, confidence level and significance, level of significance. Question on that. Question on that. If we are fine, you give me thumbs up, then we move. Please, I want us to get the footing very well. That is why I'm wasting much of time on this. If you miss this first section, everything that we'll be doing in this model will not go through. Somebody did thumbs down. Please, if your thumb was down, kindly raise your hand and come out.
Yeah,
Those who came late, the advice that I gave, please hold on. Those who came late, the advice is you have to go through the model before you come. If you want to wait and come and let me tell you, it will be like listening to a song for the first time. You'll be hearing beats in Kwa, you wouldn't know what I'm trying to sing. You know, mostly when music comes first in Ghana, we just hear it unless you listen to it frequently. So the only way you can listen to it frequently is you have to practice it frequently. When you come to the class, then I'll explain the lyrics to you and you'll be able to understand. But if you want to come and listen to the lyrics from me first, beat in Kwa na abeti. Some people are laughing. Eugene, you continue laughing. So please, I beg you, it's like eating a new food. I always tell students that learning a new topic in mathematics is like driving new for the first time. If I should give you the car right now for you to drive from here to Cape Coast,